Okay, now that we've covered square roots in and out and we're super comfortable using them, we're going to talk about how we use square roots to solve quadratic equations. Now, remember that a square root is the inverse, right, of a number being squared. So if we were to write 7 squared, right, that those two essentially cancel each other out, because if I have two 7s, that creates that group that we would pull out, right? So what we're going to do is we're going to use square roots as we're solving. Now remember, all of your linear principles still come into play if I need to move. So if this is my function and I need to move the c value over to the other side to isolate the variable, I would subtract c, subtract c. So don't lose all the fundamentals that we have. We're just going to add one more tool, which is the square root, okay? We're going to solve two different equations today, essentially ones that are in standard form and ones that are in vertex form. You'll notice that in both of these there's only one term that has an x piece, so there's an x and there's an x if we're solving for that. If there's a b value in standard form, then we will choose a different method. So step number 1, you're going to isolate the squared variable term on one side of the equation. So it's kind of the same thing with all your linear rules. You're just trying to get x by itself. Okay. Step number 2, square root both sides of the equation to undo, right, the square. And then be sure to include a plus or minus on the non-squared side to represent both the possible solutions and simplify the radical if possible. So let's just remind ourselves maybe what that one is meaning. So if I have something like a squared is equal to 9, and I ask myself, well, what squared is equal to 9? Our go-to answer is a must be 3, because 3 squared is equal to 9. Well, it's also true that if I were to take negative 3 and square it, because if we do negative 3 times negative 3, it will also give us a positive 9. So there's actually two solutions, negative 3 and positive 3. So instead of writing both of those solutions over and over and writing the positive and the negative separate, it's commonplace to introduce this sign where we write plus or minus 3. That just means there were two solutions to that. One of them was positive and one of them was negative. Now again, this is the same thing as writing these separately. And if you need to write them separately to help you, you can. But don't forget that there are two solutions to this quadratic. Okay? And then sometimes after you square root, you finish isolating the variable. So we'll look at a couple examples like that. So refer back to those steps if you need them. I'm going to scroll all the way down. So we want to get the x term by itself. So the first thing we're going to do on example A is we are going to subtract the 27 to the right side of the equation. So we get 3x squared left on the left, negative 27 here on the right. Once we have that, then we go ahead and we divide by 3. We divide by 3. And x squared is equal to negative 27 divided by 3 is negative 9. Our next step is we need to get rid of the squared, right? If we're getting x by itself, that's the only thing that's left, so we square root both sides. Now, again, if I square root a squared, that gets rid of it. That's why we're choosing to do the square root. It is the inverse of a value squared. So x is equal to, again, I'm going to have a positive solution and a negative solution, so I'm going to write plus or minus. And then I have the square root of negative 9. Now, before I write my final answer, I want to make sure that I simplify as much as possible. A radical is not simplified if there's still a negative inside. So we want to pull this out, and remember, in a square root where the index is even, that's going to be an I value. And then if I break down 9, right, the square root of 9 is just 3. So this x is equal to a positive and negative, or plus or minus, 3i. And there's nothing left in the radical, so that's what we would be looking at there. Okay. Let's try another one. I'm going to jump down here to number 4, and then we'll talk about the examples that look like vertex form. So again, if I jump down here, I want to get the x piece by itself, so I'm going to add 26 to both sides. When I do that, I end up with 6x squared on the right and 30 on the left. I then divide by 6, still getting that x piece by itself, and we get x squared is equal to 5. Again, the next step in isolating the variable x or solving is square rooting, so that will cancel. If you square root one side, you square root both. And don't forget, you need to include your positive and your negative possible solution. So we have x is equal to plus or minus the square root of 5. Very good. If we have one that's in vertex form, again, step number 1, if you look back up there and read it, is to get the x term by itself. So notice this, right, has the x in it, but even more specifically, this is the squared term. I should have said the squared term by itself. We want to get that by itself, which means we need to move this 4, right, using what we know. And then there's a 2 out front, so we're going to divide by 2 and move that over as well. So we want to get the squared term by itself so that we can square root and get rid of that squared. That will allow us to deal with the inside of those parentheses. So let's start by adding 4 to both sides. When we do that, we get 2. X plus 3 squared equals a positive 4. Again, the 2 on the left side is on the outside of the parentheses, so to get rid of it, if it's multiplying, we divide both sides by 2. That leaves us with x plus 3 squared is equal to, and 4 divided by 2 is 2. Now working from the outside in, notice the next thing we need to get rid of is the squared. We cannot just subtract the 3 out of here. It's stuck inside that squared, so I need to get rid of the square root. So we're going to square root both sides at this point to get rid of that, leaving x plus 3 on the left. And again, anytime you square root both sides, you have to consider both of those solutions that were possible. So plus or minus the square root of 2. Now your last step is just to get x by itself. So you want to subtract this 3 out of the way, and we're going to move it over. And generally we'll put it in front of the radical. Now it doesn't have a radical, so we can't combine it, right? They have to be like radicals to combine or add them. So in this case, you just put the negative 3 here, and we write plus or minus the square root of 2. Okay, 2 solutions there. Let's do one more of those. So let's look at maybe f. I like all of these, so we might do all of them. On this one, again, your x term is right here, so we're going to try and get rid of everything around that. So let's add the 2 to both sides. We get 2 is equal to 2, x minus 7 squared. We then want to get rid of, again, this 2 is on the outside of the parentheses, so I'm going to divide both sides by 2. I end up getting 1 is equal to x minus 7 squared. Now the squared is the next thing on the outside, so we want to square root both sides to get rid of that. Remember, when you square root the left side, you have to consider the plus or minus solution. Now, the square root of 1 is 1, so really this is like 1, 1, right? So this is plus or minus 1 on the left, and then you have x minus 7 on the right. And then we're going to go ahead and add 7 to both sides. Now the tricky thing about using this plus or minus sign is it's tempting to just write our solution as plus or minus, 7 plus or minus 1. But because there's no radicals there, we can simplify this all the way down. You would consider this, right, in 2 different ways, right? You'd have 7 plus 1 would make a solution of 8. Or it's 7 minus 1, because it can be a positive or negative 1, and that would be a solution of 6. So in this case, you have x is 8 and x is equal to 6. Those are 2 different values that would be true for this equation. All right, let's do one more, d. I think this one gives us a fraction. So if we look at this one, again, we're going to move things away from the squared term. So we're going to start by subtracting 3. That leaves us with 9. X minus 1 squared is equal to 5. We then want to get rid of the 9 on the outside of the parentheses, so we divide both sides by 9. And we end up with x minus 1 squared is equal to 5/9. Okay, easier if we leave it as a fraction because we can simplify radicals in fraction form. Now we're getting rid of the squared because it's the next part on the outside of the parentheses, so we're going to square root both sides. When we do that, we get x minus 1 because that cancels with the squared. And we get plus or minus the square root of 5/9. Now remember, when you do the square root of a fraction, it's really the square root of the top over the square root of the bottom. So we can split that up. And essentially, right, if that would be the same thing as plus or minus the square root of 5 over the square root of 9, which is 3 and 3, which would be 3. So when I write my final answer, I want to make sure I have, let's add this 1 over here. So we add the 1. Now my work is so confusing, I apologize. X equals, right, we moved the 1 over, so I'm going to put the 1 in front. And then we found out this was a plus or minus square root of 5 over 3 when we simplified. That's where we would stop because there is a radical piece there. So it's not like example F where there was no radical part and we could just add those numerical values together. Very good. In general, we're going to leave everything in simplest radical form. However, I'm going to jump. You can try some more of these examples, check them with the key that's posted. I'm going to jump to this middle section on the next page that says approximate each solution to the nearest hundredths. All that means is you're going to solve the exact same way, but practice kind of putting that radical into your calculator, because when we do application problems, we'll often approximate. So for example, on number 9, if we look at this one, we have something squared is equal to 3. There's nothing to move on the outside of our parentheses, so the first step on this one would be to square root both sides to get rid of the squared. When we do that, we end up with x minus 1 on the left, and don't forget your positive or negative possible solution, so x plus or minus the square root of 3. We then want to add the 1 over to the other side to isolate x. So x is equal to 1 plus or minus the square root of 3. Now there's not a plus or minus button that you're using on your calculator. This is where we have to be a little tech savvy ourselves. But one of the solutions, right, would be 1 plus the square root of 3. The other solution is where 1 is subtracting the square root of 3. So if I want to approximate that, the symbol we use for approximation is those squiggle lines, right? It tells me that these are approximate solutions instead of exact. So I'm going to go to my calculator and I'm going to plug in 1 plus and then the square root, right, which is the second squared. And I'm going to put the square root of 3. Notice here it approximates 2.73205. So I'm just going to go 2.73, and that will be my first answer here. So that's one of them. The other is when we subtract, or we do 1 minus the square root of 3. Notice we get negative 0.73. So on this one, we would say negative 0.73. Okay, so approximating just means that we're going to plug it in once we get to that end point. Let's do one more of those. This middle one, number 10, we're going to add 6. Add 6, we're trying to get the x squared by itself, so we get 8 is equal to 5x squared. Again, I'm getting x by itself, so I'm going to divide by 5, and I get x squared is equal to 8/5. To get rid of the squared, I take the square root of both sides. And because I'm going to approximate, I don't need to simplify the radical. Now, normally we would over and over and over again, right? But what we're saying is there's a positive 8/5 or it's a negative 8/5, and we're going to approximate the decimal. So let's say x is approximately, and let's put in the square root of 8 divided by 5, 1.26. I'm going to come up here and get 1.26 as one of my x's. And then negative root 8.5 would just be the negative version of that. So here's our two possible solutions here. Or we could write plus or minus 1.26. Okay. Let's do one application from this. Just practicing with the solving in this way. It says a touch tank has a height of 3 feet. Its length is 3 times its width, and the volume of the tank is 270 cubic feet. Find the length and the width of the tank because it gave us the height, right? So in this case, I'm going to draw a little diagram. Here's my touch tank, and it looks like it told me the height is 3 feet, and the length is 3 times its width. So if this is W, then this one must be 3W. The volume of the tank is 270 cubic feet. So 270 is equal to length, in our case is 3W, times width, times height. So notice once we've set that up, our volume equation, we've got 270 is equal to 3W times W. It's 3W squared times 3 is 9W squared. Notice there's no middle term on this one, so I could put everything on one side, but really everything divides by 9, so let's start there. We get W squared is equal to 270 divided by 9. It should give us 30. So in this case, we now have W squared is 30, so we would go ahead and square root both sides to get rid of that squared so that we can find out what W would be. So the width is either, and I'm going to write this, but you really don't need to, but plus or minus 30. Now if it's a length, right, or a width, it's a distance, then our negative solution is actually not a valid solution. So I'm only going to look at the positive solution in this case. So I know that it's just the square root of 30. And this one says find the width and length of the tank. So it doesn't really tell me whether to approximate or not, but if we wanted to approximate it, again, we could go the square root of 30, and we could put 5.48 feet. So we could either approximate 5.48 feet, or again, if we're leaving it as the square root of 30, we could say it's the square root of 30. So in this case, right, we know that the width is equal to the square root of 30, and the length, remember, is just 3 times the width. So we could say 3 square root of 30. Okay? Or you can write your approximate as well. Sometimes it makes more sense with applications to approximate just because you can make sense of the idea that the square root of 30 is about this many feet, versus just understanding right off the top of your head kind of what that means.